So here we're going to begin section 4.3, which is about absolute value equations and inequalities. Absolute value equations and inequalities. So we want to start off by defining what is absolute value. Hopefully you've encountered it before, absolute value. We're going to give a common definition given in college textbooks. If I were to write the absolute value of x, I don't know if you've seen this before or not, the absolute value of x is equal to one of two things. It's defined in a piecewise manner. The first case is the absolute value of x would be x if x were greater than or equal to 0. In other words, if x is not a negative number, then the absolute value of x is just itself. So if you had, for example, 0, the absolute value of 0 would be 0 itself. Or if you had the number 5, the absolute value of 5 would be 5 itself. So if you have a non-negative number, a number that's not negative, the absolute value of x is just itself. However, the absolute value of x will be minus x, or let's say the opposite of x, if x is negative, if x is less than 0. This is called the piecewise definition of the absolute value. Yeah, so let's actually see this in action, I guess, examples. So one, if I wrote the absolute value of 3, for example, well, we'd ask the question, is 3 positive or is it negative? Well, 3 is positive, so we would just keep it as 3. All right, number 2. We want to do the absolute value of 0, Well, according to our definition, 0 is not negative, right? 0 is not negative or greater than or equal to 0. So it just stays itself, 0. Okay. Third problem here. What if I had the absolute value of minus 4? Absolute value of minus 4. Well, in this case, minus 4 is a negative number. It's less than 0. So what you do, you copy down minus 4, and then you put a negative on that, or an opposite on that, opposite sign. So you get a double negative, which gives you a plus 4. Yeah, so the absolute value of a negative is going to turn out to be positive. Yeah. Well, that's the way it works. So in this first case, if I were to graph this first dude on a number line, so I got, let's say, 0 here, and 3 would be 1, 2, 3. That's the number 3. Now basically, what this is telling me, the absolute value is telling me how many units it's from 0 to 3. How many numerical units 3 is from 0 to 3. So you got 1, 2, 3 units. So that's what the absolute value is telling you. You got 1, 2, 3 blocks between 0 and 3. So if I went to the next number, 0, the one we were taking the absolute value of, here I got 0 in the middle, and let's say that's my number. It's my blue number right here. How many units is 0 away from 0? Well, it's 0 units. So, and the last situation, I got 0 here, and I got 1, 2, 3, 4, negative 4. So if you think about as your number is negative 4, think about your number as negative 4. How far is that away from 0? Well, 1, 2, 3, 4 units away from 0, so 4. Absolute value of negative 4 is 4. So what we're, let me write down some facts about the absolute value. The absolute value, number 1, is telling you how many units away from 0 your number is. So let me write that. the absolute value of a number of a number tells you how many numerical units that number is from 0 on the number line. That number is from 0 on the number line. Yeah, so it's kind of a distance from 0. Another important fact you'll notice is the absolute value is never negative. Notice in example 1, absolute value of 3 was 3. In example 2, absolute value of 0 is 0. Number 3, the absolute value of negative 4 is positive 4. Everything was always not negative. And that's because distances are never negative, right? So the absolute value is never negative. That's important, the absolute value. That's actually extremely important. It is never negative. Can be 0, right? If you got the absolute value of 0, 0. But it's never negative. So it's said to be non-negative. All right, so as far as looking at equations with the absolute value, that's what we want to get to. We want to get to working with equations with absolute value. I'm going to give you a little fact about solutions to absolute value equations. I'll give you two statements here. Number one, let's say you got a variable. If x is a variable, or x could represent a whole entire variable expression. So let's say if x is a variable and a is a non-negative, so it could be 0 or a positive, non-negative real number, then the following equation, the absolute value of x equals a, so this is the type of equation we're interested in. So you got the absolute value of x on the left side, and on the right side here we got a number, a real number that's not negative. It could be positive or it could be 0. Then this equation has solutions x equals plus or minus a. Now, how do you get that? So if I had the equation, the absolute value of x equals a, you go back and look at the definition, the original definition here at the top. Notice that there are two cases to the absolute value. X could be greater than or equal to 0, in which case the absolute value of x is x, or x could be less than 0, in which case the absolute value of x is the opposite of x. So using that definition here, we're going to break this into two cases. So case 1, what happens if x is greater than or equal to 0? Well, then you just copy down x in your equation, and you drop the absolute value bars, and you write x equals a. That would be one solution. All right, now the other case is what happens if x, so we don't know what x is, it's a variable. What happens if x is less than 0? What if x is negative? Well, in that case, you have opposite of x equals a, right, according to the definition. And then you would multiply both sides by a -1. You get x equals minus a. So there are your two solutions. If you want to put them together into one solution, it would simply be x equals plus minus a. So you can basically memorize this fact. When you have the absolute value of x equal to a, write it as x equals plus or minus a. It's going to give you two solutions there. All right. Okay, so I'm going to erase this little work here, showing you where that fact comes from. Here's a second fact we can mention. If x is a variable or a variable expression, it could be a combination of different things, variables and numbers, but let's just say if x is a variable and a is a negative real number, then this equation, the absolute value of x equals a, this has no solution, has no solution. So why would that have no solution if a were negative? If a were negative. So here we're talking about a is a negative real number. Well, it has no solution because the absolute value of x is never negative, right? Absolute value is always at least 0. Right? There's that fact there. Earlier we had fact 2. The absolute value is never negative. So if you end up with the absolute value set equal to a negative, it's impossible. It's impossible. So there would be no solution to that equation. All right, so we want to use these facts in this method for finding solutions to absolute value equations. Now let's get straight to it. Now I'll just do some exercises. Our instructions will be solve the equation. Number 1, we have x minus 1 with absolute value bars around that equal to 5. So notice that we don't have, well, first of all, notice that we have the absolute value by itself. So the first step should always be step 1, get the absolute value by itself. So absolute value is already by itself. That's fantastic. And secondly, notice that what's in absolute values is not just an x. It's a whole entire x minus 1 variable expression. So in this case, we're going to treat the x minus 1 as an entire variable expression for now. So what you're going to do, you're going to break this into 2 branches. So first of all, we're going to copy down x minus 1 and set that equal to positive 5. All right, that's one equation. And then we copy down x minus 1, that whole entire variable expression, and then equals negative 5. So x minus 1 equals plus 5, x minus 1 equals minus 5, plus or minus 5. So basically you get 2 equations, and you solve those individually. So for the first one, I'm going to add 1 to both sides. I'm going to get x equals 6. And in the second one, I'm going to add 1 to both sides. Okay, negative 1 and positive 1 cancel. I get x equals, what's negative 5 plus 1? Negative 5 plus 1 is negative 4. So you get 2 solutions. 6 and negative 4 are both solutions. You can check your answers if you want. You really don't need to check these. You don't have to check these. You will never have any problems. Like sometimes, if you remember when you're doing square root equations, radical equations, sometimes some of them wouldn't check out. In this case, that'll never happen. Your solutions will always be actual solutions. All right, here's another one. We have 2 absolute value of x minus 3 equals 9. So your goal should always be to get the absolute value expression by itself. Get the absolute value expression by itself. So in this case, you want to get the absolute value of x by itself. So first, we're going to get rid of this minus 3. We're going to add 3 to both sides. And that's going to leave us with 2 times absolute value of x. Negative 3, positive 3 cancel, equals 9 plus 3 is 12 on the right-hand side. So the absolute value of x is not quite by itself here, so we're going to get rid of that multiplication by 2. There we're going to divide both sides by 2. So on the left, the 2's will cancel. We get the absolute value of x equals what? 12 divided by 2 is 6. And then this is going to branch into 2. Once you have the absolute value by itself, branch it into 2 equations, where the first equation you're going to have x equals positive 6. And the other, you take x. What's under the bars, what's under the radical bars, just write it down in negative 6. And those will be your 2 solutions. You can check that if you like. All right, we'll check the very last one that I do. We'll save the best for last, right? So I guess I'm going to do a few more. Yeah, I'll do 4 more problems. How about 4 more problems? Number 3, I got 4 absolute value of x plus 8. Close the absolute value. Plus 6 equals, what is this, 30? So you see an absolute value showing up, so you want to get the absolute value by itself. So x plus 8 inside of the absolute value is what you want that by itself. So the first thing we have to do, we have to get rid of that plus 6 there. We're going to subtract a 6. It's going to leave us with 4 times the absolute value of x plus 8. 6 and negative 6 cancel. On the right-hand side, we're going to have 30 minus 6 is 24. All right, now we got to get rid of that 4 in front of the absolute value. So we're going to divide both sides by 4. The 4's will cancel. You get the absolute value of x plus 8 equals 24 divided by 4 is 6. All right, so now we have the absolute value by itself. Now we're going to branch into 2 basic equations. First of all, we're going to set x plus 8 equal to positive 6. Then we're going to set x plus 8 equal to negative 6. So in the first one, we subtract 8 from both sides, and you get x by itself equals 6 minus 8 is negative 2. In the second one, we're going to subtract 8 from both sides of the equation. We're going to have x by itself equals negative 6, and negative 8 give you negative 14. So negative 2 and negative 14 are the 2 solutions to this. Yeah, so typically you're going to have 2 solutions when you have solutions. All right, let's do a number 4. That sounds like the Athens train. Train coming through town. Is this number 4? Yep. Number 4. What's number 4 here? Here I got the absolute value. Oops, wrong color. It should be black. 5x minus 7. Close the absolute value. Then after that, minus 8 equals 20. All right, so we want to get the absolute value by itself, so it's not by itself, it's connected with a minus 8. So we got to get rid of that minus 8. We got to add 8 to both sides. That's going to give us the absolute value of 5x minus 7. Close the absolute value. Equals 20 plus 8, 28. All right, so the absolute value is by itself now. Now we're going to make 2 branches for 2 different basic equations. First, we're going to do what's inside the absolute value equal to positive 28. And then we're going to do what's inside the absolute value equal to negative 28. All right, so in the first equation, 5x minus 7 equals 28. We're going to get rid of the minus 7. We're going to add 7 to both sides. It's going to give us 5x by itself on the left equals 28 plus 7, 35. And we can divide both sides by 5. Get rid of the 5 in front of the x, and we'll get x is 35 divided by 5 is 7. So there's a solution. In the other equation, we're going to add 7 to both sides. We're going to get 5x on the left side equals negative 28 plus 7 is negative 21. Then to get rid of the 5 in front of the x, we're going to divide both sides by 5, and the 5's cancel. Then we're going to get x equals negative 21 over 5. Negative 21 over 5. So yeah, there are your two answers. If you wanted to, you could write that as negative 4 1/5, but yeah, or negative 4.2, but I'm just going to leave it like that. Negative 21 over 5. All right, let's do another. These aren't very hard. Number 5. What if I had the absolute value of 8x minus 1, close the absolute value, plus 12 equals, that's a plus right there, equals 5. How would I solve this? Well, always remember when you're solving absolute value equations, you want to get the absolute value by itself. So we have to get rid of this plus 12 that's outside of the absolute value. So we're going to subtract 12 from both sides. And that's going to leave us with, on the left side, the absolute value of 8x minus 1 equals, the right side, we're going to have 5 minus 7. 5 minus 7 is negative 7. Now here you'll notice that you have an absolute value equal to a negative number, an absolute value equal to a negative number. That can never happen, right? Remember the fact that absolute values are always greater than or equal to 0. They're always non-negative. Absolute values are always non-negative. They're never negative. So in this case, there's no solution. No solution. You can't take the absolute value of something and get a negative. It can't happen. So there's nothing here that you can plug in for x into this equation to get out a negative 7 here at the very end. So no solution. So that's easy. That's quite easy. You know, a lot of students will miss that type of problem, but don't miss it. It should be easy. Just remember, absolute values can never be negative. If you get a problem where it turns out to be negative, just say there's no solution to that problem. Okay, here's our last equation here. I'm going to check this one since we haven't checked any of them so far. All right, we got 7x plus 1 over 2, absolute value of all of that, and then this is equal to 3. All right, so here I already got the absolute value by itself, right? Absolute value is by itself. So I can immediately go into branching into two equations. My first equation is simply going to be 7x plus 1 over 2 equals the positive right-hand side, positive 3. And my second equation is going to be 7x plus 1 over 2 equals the negative right-hand side, negative 3. So what I have to do, I have to solve this fractional equation here. So we're going to look at an LCD of 2, and we're going to multiply both sides by 2. So I'm going to multiply here the left side by 2, and here the right side by 2. That's understood to be 2 over 1, FYI. So what happens here is that the 2 on top cancels with the 2 on bottom. We're going to be left with 7x plus 1 equals 2 times 3, 6. And from there, we're going to get rid of the plus 1 by subtracting 1 from both sides, and we're going to get 7x equals 6 minus 1 is 5. And then we're going to divide both sides by 7 here to get the x by itself. So you're going to get x equals 5/7. Okay, so that's one solution. Going on to the second equation that we got started earlier, we're going to do the same thing here. We're going to multiply both sides by a 2. Understand that that's 2 over 1 there. The 2's on top. And we're going to cancel the 2 here on top with the 2 here on bottom. That's going to give us in the second equation 7x plus 1 equals 2 times negative 3 is minus 6. Then we're going to subtract a 1 from both sides. We're going to get 7x equals negative 6, and negative 1 give negative 7. And then divide both sides by a 7 to get x by itself. And we get x is negative 7 divided by 7 is negative 1. So there are your two solutions, 5/7 and negative 1. Now, let's actually check these. I said we were going to check something. Let's check 5/7. You don't need to check these. Don't need to check these, but let's just do it. So we have the absolute value of 7 times blank plus 1, all divided by 2 equals 3. Let's check it out. So in place here, I'm going to put 5 over 7. 5 over 7 in the blank. Now understand that this is actually 7 over 1. 7 over 1. So this 7 on top is going to cancel with this 7 on bottom. So we're going to have the absolute value of 5 plus 1, all divided by 2, equals 3. All right, scrolling with that, we're going to have what? The absolute value of 5 plus 1 is 6 over 2 equals 3. And 6 over 2 is 3, so we have the absolute value of 3 equals 3. Yeah, 3 equals 3. That checks out. Right, the absolute value of 3 is 3. Now checking the other one, checking, what's it called? Negative 1. We can plug that in and see how it works out. So I'm going to have the absolute value, 7 times blank plus 1 divided by 2. Is that equal to 3? Well, let's see. Let's plug in place of the blank our solution of negative 1. So what do we have? 7 times negative 1 is negative 7. Then we got a plus 1, and then over 2. Close the absolute value. Is that equal to 3? Let's check. Well, what's negative 7 plus 1? Negative 7 plus 1 is negative 6. So we got negative 6 over 2 inside of the absolute value. Is that equal to 3? Well, let's see. What's negative 6 divided by 2? Negative 6 divided by 2 is negative 3. So we got the absolute value of negative 3. Is that equal to 3? Yeah, right. The absolute value of negative 3 is 3. So 3 equals 3. Checks out. All right. So absolute value equations aren't super hard. You just have to remember, break it up into 2. So get the absolute value by itself and break it up into 2. One positive, one negative. And if you have an absolute value set equal to a negative already, then there's no solution. That's pretty much it.